All right, ladies and gentlemen, time to deal with some cones. And I will try to do this example out and then a couple of the other examples from the notes. So if you want to have those handy and copy along as you go, that would be helpful. So here you have a cone, and I have a nice picture of it over here for you. The height of the cone is 10, which is given, and you know that the diameter of the base of the cone is 8. Water's being pumped in, so this thing is being filled up with water, and this one does not have a hole in it, so the water is accumulating. So we know that it's being pumped in at 2 meters cubed per minute, and that would mean that our rate is definitely increasing. The rate is a positive thing, versus if it were leaking out, we would have it be negative. And the question that we're trying to answer is how fast is the water level rising when the water is at 5 meters? So a couple of things that I've already written down just to get them out of the way. We know that we have our volume equation. That's what we're going to be using to get our related rates equation. And our given information is that for the H value of 5, we have a cone that has a diameter of 8, and we know that dV dt is 2 cubic meters per minute. So what is it that we are trying to find? We're trying to find how fast the water level is rising when the water is 5 meters deep. So how fast the water level is rising is really a change in height in our cone. So we are going to be trying to find dH dt. All right? So I have my equation, my given information, and what I want to find. Let me get my related rates equation. So I'm going to have dV dt, so the derivative of volume, giving me 1/3 pi. So remember that pi over 3 is just a constant. And this is exactly what we did in class the other day, that this is going to be the derivative of r squared h is 2rh dr dt plus r squared dH dt. So that's the old product rule. And we can factor out the r, we can do some simplification, but right now what I want to point out is a possible issue that we may have. We know we have dV dt. That can be an easy substitution. We want to find dH dt. That's easy enough to do because we can isolate it. What we don't have is information about dr dt. And I guess we also have to talk about, we need r, but knowing that d equals 8, that shouldn't be a problem. That's going to be r equals 4. So we have no dr dt. So we need to figure out how the heck we're either going to get rid of dr dt or find a value of dr dt to be able to do this particular problem. So that's the next piece. That's the next slide. All right, so here I have a cross section of my cone. Just consider it to be the right side of the cone. Again, there's the height of 10. Here's the radius of 4 that came from the diameter of 8. And the key here is, how do I get rid of my variable? How do I get rid of my r so that I don't have to worry about dr dt? And the way in which we're going to do that is using similar triangles. And similar triangles just say that the ratio of corresponding sides need to be equivalent to each other. So I'm going to say that 4 over r, the ratio of the two radii, have to be equal to the ratio of the two heights. So 10 over h. And even though we know we're going to let h equal 5, I don't want to plug that in here and say that h is equal to 5. I'm just doing this generically to get r in terms of h so I can get rid of it. To get rid of it, we're going to cross multiply. We get that 10r is equal to 4h. And that means that r is equal to 2h over 5, 2/5 h. So that is how I'm going to get rid of my dr dt. I'm going to just substitute in a 2h over 5 for r in my formula. To do that, I'm actually going to rewrite my equation. So remember, we started with volume as 1/3 pi r squared h. So instead of writing that, I'm going to write it as volume equals 1/3 pi, and instead of r squared, I'll do 2h over 5 squared times h. Now my volume equation is just in terms of height, and I can get rid of that drdt. So that would be volume equals 1/3 pi times 4h squared over 25 times h. So volume is equal to 1/3 pi times 4h cubed over 25. Again, trying to pull all of the non-variable stuff out in front. That would mean that volume is equal to 4 pi over 75 times h cubed. So again, I haven't taken and found a related rates equation yet. I've just gotten volume in terms of height for this particular cone. So when I go to take the derivative of this, dv dt is now going to equal 4 pi over 75 constant times the derivative of h cubed, which is 3h squared dh dt. And now I have dv dt in terms of just dh dt and h. I don't even have to worry about r at this point. So that's my new related rates equation that I'm going to use. From there, I can do some substituting of values in. So I know that dv dt is 2. This is 4 pi over 75 times 3h is 5, if you remember, and we are looking for dh dt, so I need that left in the problem. When you combine some terms, do some simplifying and solve for dh dt, you should find that dh dt is 1 over 2 pi, and the units of measure in this particular case, I believe, are centimeters per minute. So centimeters per minute. Now, actually, you know what? Now that I look at it, it is meters. So let's get rid of the centi and just call it meters. Meters per minute. All right, so there's your first look at a cone problem and getting it in terms of one variable. All right, why don't you take a second and see if you can't establish the equation, the given rates, and what you're trying to find for this particular problem, example number 8. That means press pause. Come on, I know you didn't press pause. Pause it. All right, so 1/3 pi r squared h, or pi over 3r squared h, is our volume equation. We know dv dt to be 30, and we know that the diameter of the base is always equal to the height. So I actually wrote that as 2r equals h, because I know that I have an issue with r in this equation if I'm only looking for dh dt. So that means that r is equal to h over 2. So that's going to be my substitution I'm going to use in this problem. Don't need similar triangles this time. Looking for dh dt when h is equal to 10. So again, first thing I'm going to do is rewrite the volume equation in terms of just r. I'm sorry, in just h, because I only have information about dv dt, not dr dt. So pi over 3 times h over 2 squared times h gives me pi over 3 times h squared over 4 times h. So my new volume equation is going to be pi over 12 h cubed. See if you can take it from there to find dh dt. All right, so this means our related rates equation is going to be dv dt equaling pi over 12 times 3h squared dh dt. Substituting in my values, I get 30 equals 3 pi over 12 simplifies to pi over 4 times, oops, just use that. I'll get rid of that, sorry. Pi over 4, h squared, so we're doing this when h is 10, dh dt, which is what we're trying to find. So that is going to be 30 equaling pi over 4 times 100 is 25 pi dH dt. Divide through, so dH dt is equal to 30 divided by 25, which is 6 over 5 pi. And this is a height, so feet, and it's a rate, so feet per minute. Okay, so there's your dH dt value for example number 8.